I handed out for you, or to you, I gave you a pink graph sheet. That pink graph sheet is the in-class notes sheet. Okay? And so if you want to take all of your notes on that sheet, that's fine. But otherwise, it's meant to be a supplementary sheet. We will be getting to graphing later on today, not right away. The whole day is not graphing, but we have some graphing towards the end. Okay. So we're going to talk relations and conjunction junction. What is your function? Okay. So first off, a relation is a mapping or a pairing of input values with output values. So you put something in, and then it out pops something else. Okay? I like to think of it as, how do I want to say it that you guys would know? See, I think of it as a combine because the crop goes in the front of the combine, and then out comes the grain that you're harvesting with a combine. But I know everybody doesn't know what a combine is, so I'm trying to think of a good one here, like maybe microwave is a good one. Okay? Put something in the microwave, and then it heats up, but it's not really different. It's still kind of the same. Okay? What? Muffin, yeah. Muff it into an oven or a loaf of bread into the oven. It comes out. Something a little different. Might be the same if you don't use the right ingredients. Okay? But it's more than likely just a little different. Okay? So that's what a relation is. Part of the relation is something called the domain. The domain is the set of all input values. The domain is what you put into your function, or what you put into your relation. It is the independent variable. Okay? Normally, for us, it will be the x values. Okay? We'll pick some x's to put into a function and see what value we get out of it. Sometimes the other main one for math is t values, putting in a t value into the function. Okay? And that's if we're dealing with a function that's based off of time. Range is the output values. Okay? It's what you're going to get out of the function. So that's the results. So domain is what you put in. Range is what you get out. Now for us, that's going to be our y values, because we're going to graph stuff on the x, y coordinate plane. Okay? The range can also be described as the values of the function. Okay? It's what you see. Okay? When I plug in 4 into my function, it's where that function's at. It's the value of that function. Okay? When we're talking about domain and range, we have to use set notation, which is kind of those two funky, fancy type things. Now, I am good at some things. I'm average at most things. And there are some things that I am really bad at. Okay? Right? Drawing those things is not part of my skill set. Okay? So I am okay if you just draw squiggles. Okay? But you got to have more than a couple of squiggles because I don't want it to look like a 3. Okay? So if you can draw them, more power to you. You're a better person than I am. Okay? If you can't draw them like me, join the Squiggle Club. Okay? There are 4 different ways that we can represent a relation. Okay? The first way is we can represent a relation with ordered pairs. For all 4 of these, I'm going to use the same domain and the same range, the same set, the same, in this case, the same 4 points. Okay? So one way to represent a relation is we can write it as an ordered pair. From those ordered pairs, I can find the domain, that's the 4 x's. I can find the range, that's the 4 y's. Okay? Careful when you write those out. When you write it out, though, you don't write out any repeats. Okay? So ordered pairs is one way to represent a relation. Another way to represent a relation is using a T-chart table. Okay? It's the same as the ordered pairs. Here's the point. The first one is the point 4, 2. Second one is the point 3, -1. Third one is the point -1, 5. And the last one is the point 4, -1. So we can just make our ordered pairs into a T-chart. Third way is graphically. Okay? We can represent our relation graphically. We can plot those points. Now, if your relation is a set of points, you do not connect those points. If your relation is a line or a quadratic or some other kind of function, then you connect them. Okay? But if it's just a list of points, we don't connect the dots. And lastly, this is the newer one, it's called a mapping. Okay? And a mapping has 2 areas where we have the left area is the domain and the right area is the range. And then we draw arrows that connect the points together. So for instance, the point 4, 2 is represented by this blue arrow. The point 3, -1 is represented by the green arrow. The point -1, 5 is represented by the purple arrow. And the point -4, 1, is orange. So that is a mapping. For all of those representations, is the word I'm looking for, the domain, which we go by capital D, is -1, 3, and 4. Notice how when we're writing out the domain, we don't repeat any inputs. yes, there are 2 4s in that input, but we don't repeat them. Okay. Likewise, the range is -1, 2, and 5. Again, not repeating any values. Okay. Good. So, let's find the domain and the range of the relation, and then let's draw a mapping, because that's the one that you probably haven't seen yet, is the mapping of the relation. Okay? So let's start with our domain. What are the elements of my domain? What do you got, Mikhail?
What?
You were whispering something. Oh, okay. It sounded like you were. What do you got?
-3, 2, 5, and 8.
I love it how you put them in numerical order, too. That's awesome. -3, 2, 5, and 8. Right? It's the x parts. Right? Domain is the x parts of our relation. Okay? What would the range be then?
-1, 4, 7.
-1, 4, and just 1, 7, right? Yep, exactly. -1, 4, and yes, there are 2 7s, but we only write one of them. Okay. Love it. Now what I'm going to do is I'm going to come down here just a little bit. So then, the way that I make my mapping is I take the elements. Ooh, that's a bad 5. How did I let that slide? I take the elements of my domain. I put them in one area. And then I take the elements of my range. And I put them in another area. And then now I'm going to draw arrows to and fro. Okay? So 2, -1. 2, -1 would look like that. 5, 7 would look like that. -3, 4 and 8, 7. And that's a mapping. Just another way to visually represent a relation. Questions on any of that? Good stuff. Okay. A function. Conjunction, junction. What's your function? Okay. A function is a special relation for which each input has exactly one output. Okay. What a function is, or the main test, okay, each element of the domain is assigned exactly one element from the range. The big test is there are no repeats in the domain.
no repeated values in the domain. Okay? So if I go back, is this relation a function? Yeah, it is. There's no repeats in the domain. There's a repeat, yes, in the range, but I'm okay with that. There's no repeats in the domain. Is this a function? No, because now there's two values of 4 in the domain. So this one's not a function. Oops, I double tapped. This one is a function. Okay? Decide whether each relation represents a function. Okay, well, yes or no for A. Is A a function? Is that relation a function? Nikki B? Why? No repeated numbers in the domain. So yes, this one is a function. B, function, not a function. Why not? Yeah. -1 is here and here, so therefore it is not a function. Okay? Just that easy. We can evaluate functions, and you've seen function notation before. Okay? F of x, all that fun stuff. Where's my slide with that had f of x in it? Where did it go? Did I double tap over it? Is it down here? Oops. Huh. I had a slide that talked about f of x. Apparently I took it out. Let's take a peek behind here. Huh, must have taken it out. Oh well. Alright, so functions can be evaluated at any value of x. So function notation, remember, is f of x. Okay. That's how we write it in function notation. So I am replacing, I want to know what f of 2 is. Or excuse me, f of -2. Notice here how I replaced x with -2. So what I'm going to do then is I am going to plug in -2 in place of x. 3 times -2 is? -6 minus 4 is -10. So f of -2 would then be -10. The value of my function at x equals -2 is -10. Try those two. H of 4, so I'm going to plug in 4 in for x. 2 times 4 is 8, plus 6 is 14. So H of 4 is 14. That's sneeze builder, just so you know. J of 2. Chew! Excuse me. Oops, put it in the wrong spot then. Oh yeah. Oh yeah. This is riveting internets anytime that I sneeze. Two squared is 4 times 3 is 12. 6 times 2 is 12. 12 plus 12 is 24. minus 5 is 19. So j of 2 is 19. Agree with both of those, that j of 2 was 19 and h of 4 was 14. Love it. Excited to be part of it. Okay? Function, not a function. Function, yeah. Once in a while, kind of cyclical on us. Okay? Function, not a function. Why not? Two ones, yep. Yep. No, it was tricky because I was trying to get you with the 3 and the negative 3, and that's where I think some people are like, all right, and then no, and then yeah. Good times. Okay? Now, we're getting into that graphing part. Okay? Don't freak out, Jess. Okay? All right? We'll get it. Okay? Let's look at some graphs to determine if they're functions. Okay? So, I'm going to go with, we'll go with this color. Yeah. We'll make it a little thicker, though. Yeah. So, let's go with a line. Function. Okay, love it. Let's go with cubic function, or cubic. Function? Yeah, okay. Let's go with a cycloid. Whoa, why is that not a function and you guys were so sure about the other two functions? Vertical line test, love it. Can't sneak anything by you guys. Okay? Vertical line test tells me that if I take a vertical line, and trust me, if you got a graph, you got plenty of vertical lines around there. Okay? You got your hand. Your hand can become a vertical line. You got your writing utensil. That can become a vertical line. You got your phone. The edge of your phone is a vertical line. You got the paper. You could take your piece of paper and you could just roll it over on top of the graph and slide it all the way across. Okay? All right? So you have plenty of vertical lines to choose from. Okay? All right? But if that vertical line intersects a graph more than once, it's not a function. Okay? So here, let me put a vertical line on here. So if I go, there's my vertical line. There's my vertical line. There's my vertical line for my vertical line test. As I slide this across the graph, it's only ever touching the line at one point in time. Here, as I slide this across the curve, it's only ever touching it at one point. That one I don't even have to do because right away I see that it touches there, 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 and there. So it touches at 4 spots. You can only touch once if it's a function. Okay? Love it. Excited to be part of it. Okay? A linear function is a special relation that graphs into a line. Okay. That's really the only thing about a linear function is that it graphs into a line. Okay. Now, you probably recognize y equals mx plus b as the slope-intercept form of a line. Okay? But that's not function notation. Function notation would be f of x equals mx plus b. In function notation, y is f of x. Okay? That's what we replace to get the f of x. We replace the y. So y equals 3x plus 5 is a line. Yes, it's got a slope of 3. It's got a y-intercept of 5. Love it. Function notation, that's f of x equals 3x plus 5. where again, still is a line, still has a slope of 3, still has a y-intercept of 5, still go up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. Okay. Down 3 left 1, down 3 left 1, down 3 left 1. Okay. Still do all of that. Both the same. One's just written in XY notation, one's written in function notation. Oh, there it is. That's what I was looking for. I'm trying to find that, and here it's at the bottom of this slide. Why is it over there? And remember, f of x is read f of x, not fx. Okay, that's a TV station. Okay. It has the movies. Okay. Okay. F of x. 4 ways that you can graph a linear function. Go. What are 4 ways that you can graph a linear function? Give me one.
On a graph?
What?
On a graph?
Yeah, but how? No, a line. What are 4 ways that I can put a line off of from XY form or from function form from that relation to the picture? How can I do it? No, okay, so how would I graph that? That's what I'm asking. I get it. What?
I don't know what you're asking.
I'm asking, how do I put the graph on the graph? I got the function. I can make up function after function after function. How do I put whatever function I make up onto the graph? Okay, so one way is I can use the slope-intercept form. So you would first do what? Start with a point 0, comma b. Okay, then what? And so that's going to be rise over run. Love it. That's one way that I can draw a graph of a linear function. Okay? Another way. Say it. What's wrong with the graphing calculator? Is there any downfall to using a graphing calculator, let's say, on your homework?
It's doing the work.
No? Okay? If I go over here to these graphing calculators, and I'm doing number 12 on the homework, because I graph calculator number 12, okay? And I type in f of x, or y equals 3x plus 2. I get a line. What's wrong with it?
Skill.
Hmm?
Skill. Oh, yes, yes.
What do you mean you can't see it? Because where is it? It's on here, right? Where do you need it to be? Right, but how are you going to copy it over and be exact, right? That's what I'm saying, okay? Graphing calculators are great and all, but very hard to do because you got to copy. You're actually doing more work by using a graphing calculator to graph your line because you got to do extra steps. First, you got to put it into the calculator, then you got to put it on your paper. Okay, but I'm not saying you can't. Okay, another way. Another way to graph a line. Or any function for that matter. Two more. Gotta find two more. actually done one today.
By the points.
Like, what do you mean by the points?
You do ordered pairs.
So, like a T-chart? Okay. You pick a bunch of x's, you plug x's into your function, you find the outputs, and then you graph those points. Okay, love it. Last way is probably the way that I was expecting you wouldn't get. Okay, last way is you can graph a line using the intercept. Okay, the x-intercept of a function is where y is equal to 0. And the y-intercept is where x is equal to 0. Okay? So you plug in 0 for y, and that would give you the x-intercept. You plug in 0 for x, that would give you the y-intercept. Okay? And again, connect the dots. You're probably going to stick with method number 1. Is what that's going to be your go-to jam. Okay? Secondary, you're probably going to go with a table or T-chart. Okay? Okay? So, let's do it. Okay? Let's graph some lines. Okay? So our line can either be y equals negative 3x plus 2, or it can be f of x equals negative 3x plus 2. Air moving in here. It's getting a little stale. Okay? How do you want to graph it? Method 1, 2, 3, or 4? I shouldn't even say that. How do you want to graph it? Method 1, 3, or 4? We'll throw graphing calculators out. 1? Okay. All right. Y equals mx plus b. So what is my y-intercept? 2. So that means I'm going to go up 2 from the origin, and I'm going to put a big old dot. Okay? So I've graphed my y-intercept of 0, 2. Then I'm going to utilize the rise over run. What is the slope of this line? Slope of this line. Negative 3. So that would be in fraction form. That would be negative 3 over 1. So I'm going to go down 3 and right 1. Rinse, lather, and repeat. Or I could go up 3 and left 1. Then I'm going to use something straight. Okay? So again, you could bend over your piece of paper. You could use a ruler. IDs, licenses work perfect for this. Folders, I see some people using. Okay? But you definitely want to be straight here. And not only straight, but you want to be all the way across your graph. Okay? I don't want to see lines that look like this. Okay? I want to see them go all the way across your graph. Okay? Because later on, we're going to graph lines as systems of equations, and we're going to be looking for the intersections of lines. And so we don't know where that intersection is going to take place, so we're going to extend the lines all the way across. Okay? Again, not your first rodeo of this stuff. Okay? Should just be a refresher remembrance of it. Okay? So at this time, what I'd like you to do is I'd like you to graph number 2. Okay. I'm going to do this one. You probably did it the same way we just did number 1. That's fine. I'm going to do the same line, but I'm going to do it a different method. Okay? All right? I'm going to pick different x's. I'm going to do the T-chart method, if you will. Okay? So I'm going to pick like 4 or 5 different x's. And we should have at least like a -2. We should have a 0 for sure. We should have like a +2. And then I'm just going to throw an extra one in there. Let's say Oklahoma, where the wind comes sweeping across the plain. We'll go 5. Okay? Should have at least 3. More is better. Okay? So if I put 2 into my function, 2 times -2 is -4. -4 minus 3 is -7. So I'm going to graph the point -2, 2, 4, 6, -7 right there. Then I'm going to go to 0. 2 times 0 is 0. Minus 3 is -3. And at that point, right there. Put 2 into the function. 2 times 2 is 4. Minus 3 is 1. Right there. 5. I'm going to put 5 in the function. 2 times 5 is 10. Minus 3 is 7. 1 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And then, now, I should be able to, oops, that one right there. I knew I had one once. Shabam. Make sure we go all the way across. Good. Love it. Excited to be part of it. Your homework this evening is that 9 through 31 odds. 4 of them are graphs. So I am going to hand out to you this white page of homework graphs that you can do. You can do all of your homework on this page because there's plenty of space for you to put the other problems on here too. Okay. If you want to put your homework problems on another page, on a separate sheet, that's fine too. I'm okay either way, but just make sure that tomorrow, when you turn this in, you have the graphs attached with it. Okay? Right? So we need graphs attached with this homework. Yes!